Sometimes, an unexpected event triggers a whole new area of research. This happened in Leiden as Onus's team began to investigate how materials conduct electricity at these very low temperatures. They observed that at around 4 degrees above absolute zero, all resistance to the flow of electricity abruptly vanished.
The electrical resistance dropped as if it had gone over a cliff. It was going down and down and down, and then it disappeared, or all but disappeared. And this was an astonishing thing. Nobody had ever seen anything like this before. There was nothing on Earth that had no electrical resistance.
Onus later invented a new word to describe this bizarre phenomenon. He called it superconductivity.
We have a circular ring of permanent magnets which are producing a magnetic field. And now when we put a superconducting puck over it and give it a little push, the magnetic field repels the superconductor.
The magnetic field from the track induces a current in the supercooled puck, which in turn creates an opposite magnetic field that makes the puck levitate.
It produces a magnetic field like a North Pole against the North Pole, and that's why you have the repulsion.
As the puck warms up, its superconducting properties vanish along with its magnetically induced field. For decades after its discovery in 1911, the underlying cause of superconductivity remained a mystery.
Every major physicist, every major theoretical physicist had his own theory of superconductivity. Everybody tried to solve it, but it was unsuccessful.
There were more surprises ahead. In the 1930s, another strange phenomenon was observed at even lower temperatures. This rapidly evaporating liquid helium cools until at 2 degrees above absolute zero, a dramatic transformation takes place.
Suddenly, you see that the bubbling stops and that the surface of the liquid helium is completely still. The temperature is actually being lowered even further now, but nothing particularly is happening. Well, this is really one of the great phenomena in 20th century physics.
The liquid helium had turned into a superfluid, which displays some really odd properties.
Here I have a beaker with an unglazed ceramic bottom of ultrafine porosity.
Ordinarily, this container with tiny pores can hold liquid helium. But the moment the helium turns superfluid, it leaks through.
We call this kind of flow a superflow.
Superfluid helium can do things we might have believed impossible. It appears to defy gravity. A thin film can climb walls and escape its container. This is because a superfluid has zero viscosity. It can even produce a frictionless fountain, one that never stops flowing. Superfluidity and superconductivity were baffling concepts for scientists. New radical theories were needed to explain them.